The year was 2001. The muscle car era was long gone. Emissions rules were tighter than ever. Gas prices were beginning to climb, and across America, the age of giant, torque-heavy big block V8s seemed finished. At least that's what everyone thought. Deep inside General Motors, engineers were preparing something that felt almost impossible in the modern era. An engine so large, so brutally simple, and so unapologetically American that it seemed like a machine from another time. It displaced 8.1 liters, 496 cubic inches, and it would become the last true production big block ever built by General Motors. But what almost nobody knows is that the 8.1 Vortec wasn't supposed to become a legend. It wasn't designed to dominate drag strips or headline muscle cars. It was built because GM had a problem, a massive problem, and solving that problem accidentally created one of the most underrated engines in American history. This is the story of how GM's 8.1 Vortec became the last true big block and then vanished. To understand the 8.1 Vortec, you have to go back to the 1990s. Actually, you have to go back even further than that to truly appreciate what was at stake. For decades, GM's heavy-duty trucks, commercial vehicles, and motorhomes had relied on the famous Mark IV and Generation 6 big block Chevrolet engines. The 454 cubic inch V8 had become a workhorse across America. Contractors trusted it, RV owners loved it, boat manufacturers couldn't get enough of it. Construction companies built their entire fleets around it. These engines weren't just machines, they were promises. Promises that you could haul anything, tow anything, and get the job done no matter what. But there was a problem. The world was changing. New emissions regulations were arriving. Fuel economy standards were tightening. Customers wanted more power but cleaner operation, and the aging 454 architecture was reaching its limits. The engine that had served so faithfully for so long was running out of road. Environmental Protection Agency requirements were becoming stricter with each passing year. California had its own, even tougher standards. Europe was implementing regulations that would influence global markets. The political climate around emissions was shifting dramatically. GM engineers faced a difficult question. How do you modernize a big block without destroying everything that made it great? Most people don't realize how difficult that challenge was. A big block isn't just a larger small block. Everything changes. The cooling system, the crankshaft, the cylinder heads, the oiling system, even the way the engine breathes. The physics change, the stresses multiply, the heat increases, the vibrations intensify. Every component has to be engineered to handle forces that would destroy a smaller engine. The old 454 measured 4.25 inches of bore and 4.00 inches of stroke. It had served faithfully for decades, powering everything from Corvettes to dump trucks. But engineers knew they needed more torque, better combustion efficiency, and improved durability. They also needed to meet emission standards that were written with the assumption that engines this large simply wouldn't exist anymore. So they started with a clean sheet. The result became known internally as the Vortec 8100. The numbers were staggering. A massive 4.37-inch bore combined with a 4.37-inch stroke created a perfectly square engine design. Total displacement reached 496 cubic inches, or 8.1 liters. The compression ratio stood at a relatively modest 9.1, carefully chosen to run on regular pump gasoline while producing tremendous low-end torque. Official output was rated at 340 horsepower at 4,200 revolutions per minute, and a massive 455 pound-feet of torque at just 3,200 revolutions per minute in truck applications. Marine versions produced even more. Some configurations pushed 450 horsepower with enhanced cooling systems and modified tuning designed for sustained high-load operation on the water. But those numbers don't tell the full story. This engine wasn't about peak horsepower, it was about relentless pulling power. Imagine towing a 15,000 pound trailer up a mountain pass without the engine breaking a sweat. Imagine moving a fully loaded motorhome across hundreds of miles of desert heat. Imagine doing that day after day, year after year, with nothing more than oil changes and basic maintenance. That's what the 8.1 Vortec was built for, and that's where the real engineering story begins. GM's engineers knew durability would make or break the project. They weren't building an engine for weekend enthusiasts or occasional haulers. They were building a machine that fleet operators would trust with their livelihoods. The old big blocks had developed a reputation for strength, but modern customers expected hundreds of thousands of miles. Fleet operators demanded reliability. Commercial buyers couldn't afford downtime. Every hour an engine spent in the shop was money lost. Every breakdown was a missed deadline. Every failure was a damaged reputation, so GM strengthened nearly everything. The block featured thicker bulkheads supporting the crankshaft, with reinforcements in areas known to experience stress under extreme loads. The forged steel crankshaft was enormous, machined to tolerances that would ensure balance even after years of operation. Oil passages were redesigned to improve lubrication under sustained heavy loads, ensuring every bearing received adequate flow even when the engine was working at maximum capacity under extreme heat. The cooling system received significant upgrades to control temperatures when towing at maximum capacity. Engineers studied airflow patterns, redesigned water jackets, and optimized coolant flow to prevent hotspots that could cause warping or failure. One engineer reportedly described the design philosophy as simple: build it like it'll spend its entire life climbing a mountain. And that's exactly what they did. The connecting rods were built heavier than smaller engines would require. The pistons featured designs that improved combustion efficiency while withstanding incredible forces. The main bearing caps were designed with strength margins that exceeded typical requirements. Even the accessory drives received attention. Alternators were positioned for optimal cooling. Power steering pumps were selected for durability. Air conditioning compressors were chosen to survive harsh environments. But there was another challenge: breathing. An engine this large consumes an incredible volume of air. At full throttle, every piston was traveling 8.74 inches during each crankshaft revolution. Multiply that by 8 cylinders spinning thousands of times per minute, and the airflow requirements become enormous. We're talking about hundreds of cubic feet of air flowing through the intake system every minute. The engineers responded with advanced Vortec cylinder heads featuring improved intake and exhaust flow compared to previous big blocks. Port designs were optimized using computational fluid dynamics, a technology that was becoming increasingly sophisticated in the late 1990s. A sophisticated sequential fuel injection system replaced older technology, with individual injectors firing in precise sequence to maximize efficiency and minimize emissions. The intake manifold was optimized for low-end torque production, with runner lengths and plenum volume carefully calculated to enhance the power band where truck owners actually needed it. The exhaust system was engineered to balance back pressure with flow, helping the engine produce torque while meeting noise regulations. The result was an engine that could generate immense pulling force without needing high RPM. Maximum torque arrived at just 3,200 revolutions per minute, which meant the engine could work efficiently without screaming. But there was a problem. The automotive world had changed. Back in the 1960s, giant displacement engines were symbols of performance. Bigger was always better. Cubic inches meant power, and power meant respect. By 2001, they were becoming dinosaurs. Ford had largely moved toward modern modular engines, phasing out their traditional big blocks in favor of smaller, more efficient designs. Chrysler's legendary big blocks were long gone, replaced by Hemi engines that, while impressive, represented a different philosophy. Smaller engines with better efficiency were becoming the future. Turbocharging was advancing. Variable valve timing was becoming common. Direct injection was on the horizon. So while GM engineers had created a masterpiece of heavy-duty engineering, they were launching it into a market that was slowly moving away from everything it represented. And then, the real challenge started. The 8.1 Vortec entered production in GM's heavy-duty truck lineup, including the Chevrolet Silverado HD and GMC Sierra HD. It also appeared in Suburban 2500 models, commercial chassis vehicles, marine applications, and motorhomes. Workhorse Chassis used it extensively. Marine manufacturers installed it in everything from fishing boats to luxury cruisers. Customers immediately noticed something unique. The torque delivery felt endless. There was no turbo lag to manage, no waiting for boost to build, no complex power band to understand. You pressed the accelerator, and the engine responded with immediate linear force. A diesel might produce more torque overall, but the 8.1 delivered smooth gasoline power without turbo lag or complex emissions equipment. No diesel particulate filters to maintain, no DF fluid to monitor, no regeneration cycles to worry about. RV owners especially became devoted fans. Cross-country travelers discovered they could tow massive loads while maintaining impressive reliability. Families crossing the Rockies in 40-foot motorhomes found the engine pulling grades that would have challenged smaller power plants. Marine operators appreciated the engine's durability. Fishing charter captains ran them hard day after day in saltwater environments. The engines kept running. Commercial fleets valued its simplicity. Fleet mechanics appreciated working on an engine that didn't require specialized diagnostic equipment for every service. Parts were available, repairs were straightforward, and despite its size, the Vortec 8100 developed a reputation for longevity when properly maintained. Some examples exceeded 250,000 miles without major repairs. Others crossed 300,000 with nothing more than routine maintenance and minor component replacements. Several fleet operators reported engines surviving years of severe duty service with only oil changes, filters, and occasional tune-ups. Stories began circulating in enthusiast communities about 8.1 Vortecs that simply refused to die. Engines with original internals still pulling heavy loads after a decade of hard use. Motorhomes traveling coast to coast without issues. But fuel economy? That was another story. You can probably guess what happened next. An 8.1-liter gasoline V8 isn't exactly designed for efficiency. Owners frequently reported fuel economy figures between 7 and 12 miles per gallon, depending on vehicle weight and usage. Unloaded highway driving might reach the upper end of that range. Heavy towing or city driving could drop to single digits. In a heavy motorhome, numbers could drop even lower. Crossing mountains with a full load might see fuel consumption measured in gallons per hour rather than miles per gallon. For many buyers, that wasn't a problem. They weren't purchasing the engine to save fuel. They were purchasing confidence. They were buying the certainty that they could handle any load, any grade, any situation without worrying about whether the engine could handle it. But market forces were becoming impossible to ignore. And then everything changed. The early 2000s saw dramatic advances in diesel technology. GM's Duramax diesel program was rapidly evolving. The 6.6-liter Duramax V8 offered tremendous torque, excellent towing performance, and significantly better fuel efficiency. At the same time, emissions standards continued tightening. Each model year brought new requirements. Each regulation made traditional big blocks harder to justify. Fuel prices fluctuated upward. The early 2000s saw gas prices climbing to levels that made Americans reconsider their vehicle choices. Consumers began prioritizing efficiency more than ever before. Suddenly, the advantages of a giant naturally aspirated gasoline engine looked less compelling. The numbers told the story. While the 8.1 produced 455 pound-feet of torque, newer diesel engines were delivering over 500 pound-feet and eventually far more. By the mid-2000s, diesel trucks were producing 600, then 700, then over 900 pound-feet of torque, and they did it while consuming substantially less fuel. For fleet operators, the economics became difficult to ignore. Better fuel economy meant lower operating costs, more torque meant better towing capacity. Diesel engines were winning on multiple fronts. But here's the fascinating part. Even as sales declined, the people who owned 8.1 Vortecs rarely wanted to give them up. Why? Because reliability creates loyalty. Many owners discovered that the engine's simple architecture made maintenance relatively straightforward. Any competent mechanic could work on it. Parts were available at regular auto parts stores. There were no turbochargers spinning at over 100,000 revolutions per minute that could fail catastrophically. No complex variable valve timing systems with solenoids and actuators to malfunction. No direct injection hardware with high-pressure fuel pumps and precise tolerances. No cylinder deactivation systems with lifters that could stick or fail. Just displacement. Massive, glorious displacement, and lots of it. By the mid-2000s, however, the writing was on the wall. The market was changing faster than the engine could adapt. Corporate average fuel economy standards were tightening. Gas prices continued their upward trend. Diesel technology kept improving. GM faced difficult decisions regarding production costs, emissions compliance, and future product strategy. The company could continue investing in a platform whose customer base was shrinking, or it could focus resources on newer technologies that aligned with where the market was heading. The answer became inevitable. Production of the Vortec 8100 gradually came to an end after the 2006 model year in most truck applications. Marine versions continued slightly longer, but eventually they too ceased production. Just like that, the era of GM production big blocks effectively ended. No replacement arrived. No direct successor emerged. The lineage that stretched back through the legendary 454, 427, 396, and countless other Chevrolet big blocks was over. An entire chapter of American automotive history closed quietly, without ceremony or fanfare. But that's not where the story ends, because something unexpected happened after the engine disappeared. Its reputation grew. Years passed, then more years. Owners kept driving them, odometers kept climbing, the engines kept running, mechanics kept praising them, telling customers about the last great big block. RV forums filled with stories of extraordinary durability. People shared photos of odometers showing 400,000 miles with original engines still going strong. Truck enthusiasts began searching for clean examples, recognizing that these engines represented something that would never be built again. And slowly, people started realizing what they had lost. The 8.1 Vortec wasn't merely another truck engine. It was the final expression of a philosophy that had dominated American engineering for generations. When you needed more power, you added displacement. When you needed more torque, you made the engine bigger. When you needed durability, you built everything stronger. Simple, effective, American. Today, modern turbocharged V6 engines can produce horsepower figures that would have shocked engineers in the early 2000s. Half-ton trucks generate towing numbers once reserved for heavy-duty workhorses. Technology has moved forward in remarkable ways. Engines are more efficient, cleaner, and often more powerful than ever before. There's no denying that. But there is something uniquely satisfying about an engine that solves problems through sheer mechanical presence. The 8.1 Vortec represented the last moment when a major automaker looked at a challenge and responded with nearly 500 cubic inches of cast iron confidence. No turbochargers to add complexity. No hybrid systems to engineer. No downsizing strategy. Just 8 massive cylinders doing what American V8s had done for decades, only refined and improved with modern technology. And that's why enthusiasts still talk about it. Not because it was the fastest, not because it was the most efficient, not because it was revolutionary, but because it was the end of something. The final chapter of the traditional American production big block. A machine built for work, built for endurance, and built without apology. In the end, the 8.1 Vortec didn't vanish because it failed. It vanished because the world changed around it. Emissions rules tightened, diesel technology improved, fuel economy became a priority, market demands evolved, consumer preferences shifted toward efficiency and technology. But for a brief moment, GM gave the world one last giant V8, one last true big block. And decades later, people are still searching for them, still towing with them, still rebuilding them, still telling stories about them. Owners who bought them new refuse to sell. People who need serious towing capacity seek them out specifically. Marine operators who found reliable examples hold on to them. Because some engines don't become legends through racing victories or record-setting horsepower. Some become legends simply because they refuse to quit. And that's exactly what happened with GM's 8.1 Vortec. The last big block didn't go out with a whimper. It didn't fail or fall apart or prove the critics right. It simply became obsolete in a world that had moved on. But the people who understood what it represented, who needed what it offered, who experienced what it could do, they never forgot. and they never will. If you enjoyed this story, let me know in the comments which forgotten engine you think deserves a deep dive next. And make sure to subscribe so you don't miss the next piece of automotive history, because some of the greatest machines ever built are the ones most people have already forgotten.